We are Team 11260 Up-A-Creek-Robotics, here to talk about intake design. Intakes are a broad category of mechanisms that use rotational movement, usually powered by motors, and friction to move game elements into the robot. The reason we decided to talk about intakes is because they are one of the most fundamentally critical mechanisms in competitive robotics, and have been extremely successful in the world of FTC. Intakes are almost always the best and fastest way to pick up objects in any game. This is because intakes require far less precision and take less time to pick up objects than a claw does, which is the main alternative. If we look at past FTC, FRC, and VEX games, we see that in the past 4 or 5 years, a huge amount of the top teams used intakes. We highly recommend watching videos of previous year's games and looking at top performing robots to gain inspiration from the way they use their intake and better understand why they chose that mechanism. Some specific games that would be great to look at are the FTC games Rover Ruckus, Relic Recovery, and Velocity Vortex, or the FRC games Power Up, Destination Deep Space, and Steamworks.
The first step in building an intake is game analysis. You must consider the size and shape of an object you're trying to pick up, and based on this, you can narrow down the choices of intakes that you have. For example, in Rover Ruckus, you had to build an intake capable of picking up 2 objects that were different sizes and shapes. Your intake design will also change depending on how many objects you need to grab. For example, in Rover Ruckus, you could pick up more than one object at once, which favored intakes that could grab more than one object at once. But in a game like Skystone, you could only have one stone in your possession at a time. So this greatly affects which intake you will choose. And some intakes are more effective at grabbing multiple objects or single objects. After you analyze the game and figure out what elements you are required to manipulate, you must consider what intake options are available. When choosing between intakes, you need to consider the rest of your design to make sure you know where the game elements are going after they enter your robot. In this case, it could be a pass-through to a different mechanism used to score, or it could just be straight to your scoring mechanism. In the following slides, we will explain many different types of intakes and why they are useful in some cases and not in others.
The first intake we are going to cover is a brush style intake. The thing about brush style intakes is that they're super easy to build, but it's really hard to get the right material in your brushes. What you're looking for is you're looking for a material that's hard enough to not bend around what you're trying to pick up, but not so hard that it will snap if it hits something that's not able to be picked up. For our team, we used springs in Rover Ruckus. That material was able to pick up those minerals, but if we ran it against the crater, it would not snap our springs. The other main thing about brush style intakes is that it usually uses one motor on one side, but you need to have multiple sets if you want to push things farther, and it's not very good for picking up large items. The most common type of intake in FTC would be the horizontal wheel intake. Horizontal wheel intakes are really versatile because they have the ability to pick up different sized objects when designed properly, and they have the ability to allow for less accuracy in your driving, due to the fact that if you run into an object not at the perfect angle, These intakes can usually help to reorient the object to come in at the proper angle. The one downside of horizontal wheel intakes is that they're not great for picking up multiple or smaller objects, but it's able to be made up by the fact that you don't have to be as accurate, and they're great at picking up larger objects like last year's season's Skystone and their long rectangular bricks. Designs allow for your wheels to sometimes expand out, and that's great if you're trying to pick up objects that are longer one way than the other. It's able to come in and reorient the object by expanding to be pulled in the correct way. A lot of teams did this last year.
Another type of intake is the rubber band sprocket. This intake is great at intaking balls and spherical objects of any size. It's easy to build and the materials are cheap. This intake can be used to pick up objects off the ground or pass them through the robot like a conveyor belt, though it is not as good at picking up large square or rectangular objects, though it can be used to pick up small cubes like seen in Rover Ruckus. This design can reasonably use 1 or 2 motors, though it is most common to use 1 for a good intake when having small elements, though may require 2 when dealing with larger elements and possibly a conveyor system. It was most commonly used in the games Velocity Vortex and the Vex games Turning Point and Nothing But Net.
Vertical wheels are a type of intake that use an upper and lower set of vertically aligned intake wheels. Designs generally use either 1 or 2 motors, with the number depending on if a power transfer system like chain is present. This intake is most commonly seen on FRC robots. Some of the advantages of a vertical wheels intake are that it is very fast at picking up large balls that are soft, an example being the FRC 2019 Destination Deep Space game element. This intake also allows for more control over large individual game elements, such as the ball, where you're going to be picking up one large object and keeping it within the intake instead of transferring it to some other storage mechanism. The disadvantages is that it is worse at picking up firm or small objects than many other intakes. It also may require more testing than other intakes because it is more rigid than something like a rubber band sprocket intake. So it's less accommodating of objects of different size, so it needs to be built more precisely. Intake designs are not limited to the previously mentioned categories. A unique intake or variant of another design can be very advantageous in certain games. An example is FRC Team 1619, which used a variation of the vertical wheels intake consisting of smooth rollers instead of intake wheels in the 2019 game Destination Deep Space.
We're going to move away from actual types of intakes. We're now going to move into the design process that we use when building intakes. And the largest part of that is CAD. CAD is a really strong tool in its ability to let you create assemblies, which can help show you your design without having to put hours upon hours into actually producing your design, and then just to realize that it doesn't fit or it doesn't work the way you want. CAD, how it does it is it allows you to make simulated models, and when you put that into something you've already built, like your robot in CAD, it can show you if something will fit, run into something else, or if you have to change your design because there's something that's not right or you don't have the correct parts. Another important part of the design process is prototyping. Prototyping allows you to test certain aspects of your intake or to test certain things you will use in your intake, like wheels or materials for a brush. And the main reason you will do this is so that if you make a design that uses something that will not work in your intake, you can know that before you spend time making an intake or making a CAD design. And the other major part about making a prototype is that if you don't want to CAD it, you can still test your idea without spending all the time that it would take to make a full-blown intake. When it actually comes to building your intake, there are a few things you want to keep in mind. One of which is what kind of system you want to use. And by system, I mean what kind of parts you want to use. Because there are different kinds of parts, right? You have Rev parts, you have Vex parts, you have 3D printed parts. And using all three at once can be somewhat of a hassle as you're trying to accommodate your 3D printed parts or trying to mix your Rev parts and connect them to your Vex parts. Using a single modular system is a great way to keep your intake system to be organized and to increase its reliability, as you're not having to try to accommodate for things that these systems might not be designed to accommodate. And when it comes to including 3D printed parts, make sure that you are measuring and making sure that you're cutting your parts for the right size.
Testing is one of the most important parts of the design and robot building process. When testing your robot, and specifically intakes, you have to look at certain parts to figure out how to improve. One thing to look for when testing an intake is how fast it is and how fast elements are transferred to the next part of your robot. In FTC games, there are generally overall cycle times when scoring points. This can be seen in the past 4 or 5 games, if not more, and increasing the speed of any part of your robot will reduce your cycle time, allowing you to score more elements and get a higher score. Other important aspects include how easy it is for the drivers to align with the target and how well your intake can grab items off the ground or wherever you have to get them from. Some examples are from Rover Ruckus when going in and out of the crater, or in Skystone you could test how easily your intake could grab stones out of the quarry or how easily it could grab them off the wall. Some problems with an intake can be that it is too fast and elements bounce off instead of getting sucked in, which is most apparent in wheel-style intakes like horizontal wheels and vertical wheels. With these things in mind, you also have to be conscious of jamming and consistency, which is another reason to conduct many trials and drive your robot tons before competition. Consistency is definitely the most important part of doing well in robotics. This is because your robot can be fast, but if it breaks, it's very slow or may not even work. And so it's not always better to be faster if you can be more consistent. My team especially can attest to this from 2018 in Rover Ruckus and in Skystone. One example of this was at Worlds when our robot broke down in the middle of one of our qualification matches and caused us to lose. Even if we had been slower, but our robot didn't break, we would have won the match. And in Skystone, this is the same case. Our lift broke down in the state finals, which caused us to lose the match, and even if we were slower, we may still have won. To test this, well, conducting lots of trials and recording data is very important, especially for notebook reasons. When you experience a jam, you have to find out what is causing it and brainstorm ideas to what might fix it. This can only be done in specific robots. After testing your intake to find out what needs to be improved, there are many different ways to do so. Some ways that our team and many other teams have seen include testing different motor speeds, wheel sizes, and much more. And these things can affect the grip on an object when it is being grabbed and will affect the speed at which it enters the robot. Depending on what type of intake you use, changing small details may make a big difference on how effective it is. For example, a brush intake can benefit greatly from testing different speeds and stiffnesses of tubing. Our team saw this when testing our Rover Ruckus intakes, and we had to try many different types of stiffnesses and tubing types on our brushes until we got them to work very well. When looking to improve your robot, don't be afraid to redesign and use a completely different intake if you think you have time and think it would work better.
A very beneficial practice for any team is competition reflection. Competitions are a valuable opportunity to add to the design process. Competitions can be thought of as a test of your robot, where reliability and effectiveness in the game are measured. These observations may be more valuable than those from tests at regular team meetings, because in competition, the robots must endure the strain of playing with other robots, and the game is testing exactly what the robot is designed for. Competitions also allow an opportunity to compare your robot with other robots to look for the areas in which your robot is faster or more effective than the competition, or where other robots are faster or more effective than your robot. Competitions are also a great opportunity to meet other teams and gain inspiration from their robots if they have a new idea that you hadn't thought of how to do a certain task in the game. It can be very valuable. And competitions, lastly, are also a great checkpoint and point of reference for the build season and for the robotics season, because looking back at a competition, you can see what changes you made to the robot since the previous competition, and then you know how long those changes took and how well the process went, so you have a better idea of what you're able to change in the time between this competition and the next competition. Thank you for listening to our presentation. If you have any questions about content, or if there's any way that our team can help your team, please feel free to email us at 11260.ftc@gmail.com. Thank you.